I am so pleased to welcome Jesús Moreno-León. He's a computer science researcher and professor at the University of Seville. As I said, I've known him for many years. He brings this extensive experience from various roles, leadership roles, as well at the Spanish Ministry of Education, as well as his deep understanding of pedagogy and the work that he's done at now, I might pronounce this incorrectly, Fundación Telefónica's 42 campus network across Spain. He's also the co-director of Programamos, an award-winning non-profit organization that promotes computer science education from the earliest of years. And in today's session, Jesús will discuss current approaches to measuring and evaluating AI literacy. And he's going to introduce an assessment instrument that's been used in large-scale studies with thousands of primary and secondary students across Spain. And he's going to reflect on both the strengths and its limitations, like all good researchers do. And he'll also share some recent developments in designing a new instrument that's informed by SEAME, which is the framework that I really rather love. So I'm personally very much looking forward to hearing his insights, and I'm sure you are too. So over to Jesús.
As Jen said, I currently work at the University of Seville, which is in the south of Spain, in the region of Andalusia. But before joining the university, I spent more than a decade as a secondary school teacher. And together with a group of teachers from different educational levels, we created a non-profit organization called Programamos, which Jane pronounced perfectly in the introduction. Programamos. In English, it could be something like we program or we code. And the original idea was simple, to openly share under a free license all the teaching resources that we were using in our lessons, so that all the teachers could start introducing programming more easily. But the initiative kept growing, and today it is one of the main references on computational thinking in Spain and across Spanish-speaking countries. For instance, we offer free online courses that tens of thousands of teachers from more than 100 countries have taken. And as we worked with so many teachers, one message appeared again and again. Okay, the resources are great, but we need tools that help us assess our students, right? So together with Gregorio Robles, who is a professor at Universidad Rey Juan Carlos in Madrid, and he was my PhD supervisor, we created Dr. Scratch. Dr. Scratch is a tool that analyzes Scratch projects and offers feedback on several dimensions of computational thinking and on good programming practices, as you can see in the picture. The goal was to support learners so they could improve their projects iteratively, and also to support teachers by giving them a tool to help them evaluate the student work. In recent years, Dr. Scratch has grown even more thanks to Gregorio's collaboration with Northeastern University in Boston. And Dr. Scratch now even includes a chatbot assistant to make the feedback even more interactive. Well, a bit later, Marcos Roman, who is a professor in the Spanish National University for Distance Education, joined also the research group. And as part of his PhD, he developed the computational thinking test, the CT test, which is a 28-item instrument designed to measure computational thinking development in students aged 10 to 16. The test is now available in many languages and has been widely used as a reference tool in multiple research studies. Also, at Universidad Rey Juan Carlos, Maria Zapata and Estefania Martin created the Beginners CT test, which evaluates computational thinking in a platform for even younger learners in early education. This work was actually presented here in this Raspberry Pi Foundation Research Seminar Series back in 2021. Well, connecting all of these efforts, for a period of time, I worked at the Ministry of Education, designing initiatives to promote computer science learning across all educational levels. And one of these initiatives was the School of Computational Thinking and Artificial Intelligence, involving more than 400 teachers and 7,000 students in each edition. At the time, it was probably the largest study ever conducted to evaluate AI literacy in school. And this was 2019, also known as year 3 before ChatGPT, a very different world, right? Well, the program was structured by age groups. In early childhood and the first years of primary school, students worked with unplugged activities. In upper primary and lower secondary, students created AI models using machine learning for kids, and then programmed scratch projects that use those models to solve problems from their environment and their interests. And older students in upper secondary and vocational training created mobile apps using these models. The results of this work are published by the Ministry of Education in a book and also in a project website that includes the best practices documented by the participating teachers. What worked well, what didn't work so well, things to consider if other teachers want to replicate the initiative, require resources, and so on. I honestly think that it is a very valuable resource for the educational community. And the thing is that the ministry also wanted to measure the impact of the initiative to see whether students were actually developing computational thinking and learning about AI. And for computational thinking, we already had strong instruments. We have Scratch, we have the computational thinking test, the beginner city test, and even an app inventor, a doctor app inventor developed by Gregorio's team to assess the apps created by the older students. But for AI literacy, we had almost nothing. So based on the AI for K-12 framework that has been discussed in this seminar series by several speakers, we also reviewed previous research, borrowed ideas from different studies, incorporated some questions similar to the ones used in the Machine Learning for Kids platform, and we also drew inspiration from several AI literacy MOOCs. And from all of that, we created what we call the AI knowledge test, a 14-item multiple choice instrument. And as you can see here in the slide, that you can see a couple of items. The items focused mainly on AI for K-12 ideas number 3 and number 5. That's it. Computers can learn from data, and AI can impact society in both positive and negative ways. Because those were the ideas that the project addressed more deeply. So when we looked specifically at AI learning, the results were very interesting. We found a significant improvement in students' AI knowledge with a moderate effect size for the year 4 to year 8 group. But for older students, the effect was smaller because we detected a ceiling effect. Many students were already scoring at the maximum, which prevented us from seeing differences that may have existed. So we learned some important things from these experiences. Regarding the tools, although machine learning for kids has many strengths, we realized that we needed tools that were free and open source, that did not require registration, that did not rely on APIs or external services, and did not send any data to the cloud. Ideally, everything should run in the student's own browser. I was really happy to hear similar reflections in previous seminars, for example, in the talks by Enrica and Matti, and also by Carl Giemel. And in terms of the AI literacy assessment instrument, it was clear that it needed a higher ceiling, as we were discussing, but also it needed a broader scope. And it needed to address common misconceptions, something that we didn't fully achieve in the first edition. And again, I enjoyed very much hearing something very similar in Francis' seminar when he talked about misconceptions. And well, this is how Learning ML was born. This is a tool that meets all of those requirements, allowing learners to build different types of AI models and use them in different programming languages. And Learning ML is developed by Juan David Rodriguez, who joined the research group in 2019 to start his PhD. Well, actually, the tool was also presented in this seminar series, and in 2024, it received the All Digital Award for Best Educational Resource in Europe. To validate Learning ML as a tool for AI literacy, we conducted several studies. The slide shows one of them, an online study we ran during the COVID pandemic. It demonstrated the effectiveness of Learning ML and of the pedagogical approach we used. Learning AI by building systems that use AI to solve problems and communicate ideas. In the picture, you can see one of the participating students who created an app to help visually impaired people move around a house or a school. One modification that we made was to include questions to address misconceptions, as I mentioned earlier. In the pretest, as you can see in the picture maybe, well, many students defined AI as something necessarily related to robots, probably influenced by how AI is presented in the media, right? But in the pretest, in the post-it, sorry, after the intervention, the word robot no longer appeared among the most central terms in students' definition. Students now demonstrated a much clearer understanding of what AI actually is. And this was the kind of work we were doing when ChatGPT and generative AI arrived. And at least in Spain, the educational community kind of lost its direction. I'm curious if something similar happened in your countries too. Perhaps we can talk about that later. But in Spain, suddenly many institutions stopped working on AI literacy and shifted to offering just training on prompting and on the consumption of commercial closed AI assistants. So we started wondering, these teachers who are learning to use generative AI assistants, do they actually understand how these systems work? Because if they don't, it's very difficult for them to use them properly, right? For example, they may attribute capabilities to the systems that they do not have. So we designed new items focused on generative AI, and we gave them to teachers who were taking part in professional development courses on prompting. Here you can see an example of those items, specifically about how large language models generate text. I'll give you a minute to read the question and think about your answer. But when we offer these questions to teachers who were involved in a course about prompting, about consuming AI generative assistants, you can see here the results. And as you can see, most teachers did not understand how text generation actually works. Almost 50% of them believe that the system consults a database of real facts before writing a response, right? Well, for the classroom, I really like this simulation because it helps us understand how LLMs actually generate text. Perhaps you guys already know it, but for those who don't, the creator asked ChatGPT to complete the sentence "intelligence is," and it asks ChatGPT to complete the sentence hundreds of times, and then visualize the process behind each answer. Every partial phrase, intelligence is the ability. Well, each phrase becomes a point in the visualization. And what we see is a branching tree of possibilities. At each step, the model assigns probability to many possible next words and continues along on one of those branches. For me, it's a powerful way to see that LLMs are not looking at facts or retrieving stored sentences. They are navigating a probability space, step by step, generating the next word based on patterns learned from data. And because this process is stochastic, the same question can lead to many different responses. This second resource is also a great visual tutorial. It walks you through the key steps, how a prompt is split and converted into a numerical representation, and especially how the self-attention mechanism works, the part of the model that decides which previous words are more important when predicting the next one. And although we often talk about words, the tutorial also shows that these systems do not actually generate words. They generate the most probable next token, which might be a full word or part of a word or even punctuation. And I really think this tutorial is useful because behind the scenes, you can see that the model is not reasoning about meaning like a human. It is simply performing a sequence of probabilistic calculations based on these tokens. Okay, now let's look at an item about image generation. Again, please take a minute and reply in the chat. But again, if you take a look at the responses from teachers who were involved in a course about prompting and they were using this kind of AI assistants, we can see that more than half of the teachers did not understand the implication of these systems regarding plagiarism and copyright. To illustrate this issue, you can see on the slide 2 examples from a very interesting investigation. The researchers show that models like Midjourney can generate images that are almost identical to real film frames when you use very specific prompts. But what is even more worrying is that they can also reproduce copyrighted material even when the prompt is extremely simple. In the images on the left, the only prompt was animated toys. And on the right, it was just screen cap. And yet the results still resemble protected characters or scenes. Over the last weeks, since the release of Nano Banana 3, I'm pretty sure you have found similar examples on social media. People sharing that when they type something as generic as husband sitting on a couch, The model produces images that look exactly like well-known actors, clearly taken from real films. I think this illustrates very clearly why the discussion about copyright and visual plagiarism is so important when we talk about generative AI in education. All right, and here is a final item about the environmental impact of generative systems. In this case, a stable diffusion Excel. Please take a look at it, please. Well, now we can see that we have more debate here in this question. It's not that clear, right? Well, something similar happened to us as well. And as you can see in the slide, a large proportion of teachers were not aware of the real environmental cost of the system they were actively using, right? For this item, we use data from this research paper, which presents in a very accessible way how different AI tasks have very different environmental footprints. And you can immediately see that tasks involving generative models, such as image generation, are much more energy intensive than simpler tasks like text classification. One of the key conclusions of the article is that the advantage of using small specialized models for specific tasks. These smaller models can achieve the same and sometimes even better performance while having a much lower environmental impact compared to huge general purpose models. Well, as we have seen from the results of these items, even teachers who were actively training to use generative AI systems did not fully understand how they work. So simply using or consuming these tools is not enough to develop real AI literacy. Fortunately, in recent years, some very interesting proposals for AI literacy have been published. They all promote a broader approach in which students not only use AI systems, but also build their own, so they can understand how they work, what they can really do, and what their limitations are. And this is why we are designing a new assessment instrument aligned with these proposals, including the SEAME framework, which I actually learned about thanks to Jane during the last WIPSI workshop in Munich. And I'm going to show you a few of the new items we are designing. This is an example of an item at the engine level of the SEAME framework. The idea is to interpret a decision tree created by a student. All right, I'm going to show you another item. This one is related to embeddings, which are used to represent words numerically. This could be another example of an engine level item from the SEAME framework, right? And finally, I'm going to show you another one. This could be an example of an item at the model level of the SEAME framework. So these are the kind of items that will be part of the new instrument that we are completing, and we hope to test this new instrument in the second quarter of 2026 with students of different ages and also with teachers. So if anyone is interested in trying it in their community, please send me an email and we can talk about it, of course. Okay, to finish with the presentation, I'd like to share a quote by Charles Percy Snow from 1961. 1961. And well, as you can see, he already highlighted the importance of understanding algorithms in society, something that continues to guide our work today. We are not creating this AI literacy instrument because AI is fashionable. We are doing it because we genuinely believe it can help prepare people for living in a society where AI has a huge impact. And in that way, perhaps we could avoid situations where toys like this are sold and families actually buy them, or situations where companies release products that encourage teenagers to harm themselves, and teenagers use them uncritically, almost as if they had magical powers, or situations where politicians, like this US senator, want to make decisions about a technology whose functioning they clearly do not understand, right? Well, thank you very much. That's what I wanted to share. You can actually download the slides using the QR code or the link. Well, thank you so much for your attention.
Huge thank you to Jesus, as always. Can we give him a big kind of round of applause? We'd love to see you on the 27th of January for our next seminar, which is going to be with Salome, who is from our research team, and she's going to be talking about teaching about AI and data science using unplugged approaches. And so, we're really excited because that's kind of at the other end of the spectrum, really, in that it's like, how do you learn things, but without, by using physical artifacts and unplugged activities. So please, if you could fill in our attendee survey, that would be wonderful. Yeah, and it's crazy, I'm going to say happy Christmas or happy winter holidays or whatever it is that you kind of say at this time of the year. But anyway, thank you very much. If you want to turn on your mics, you can say goodbye.